Hello everyone, welcome back to my channel AWS DevOps with Lemon. Once again, thank you so much for all your support and feedback for my videos. It really encourages me a lot to post more and more videos. So in today's video, we are going to talk about how to set up MySQL RDS in AWS. So there are multiple managed services for the relational databases what AWS offers. And as part of that, today we are going to do a lab on how to set up a MySQL relational database on the AWS cloud. So before we get into the lab, I want to just give you a preview on what are all the various databases services that AWS offers. So one is, it is offering the relational database service, RDS, which includes the relational databases like MySQL, MYSQL, Oracle, PostgreSQL, etc. So if at all you want to set up any of these relational databases on the cloud, you have the RDS service available. Then we have DynamoDB, which is typically for storing the unstructured data. So if at all you want to stand up a database which is going to host unstructured data, just like we have MongoDB, CassandraDB, etc. in the market, right? So for that you can use the DynamoDB service within AWS, which is typically for the unstructured data. Then we have Elasticcache, that is another database service from AWS, and this is typically pointing to the service named Redis, which is used to improve the performance of your applications. So we have a service called Redis, which is going to hold a database temporarily in the memory, and that is going to improve the performance of the applications. Then we have Redshift, which is a data warehouse service provided by AWS. And we also have Aurora, again, which is the managed service for MySQL and PostgreSQL databases, if at all you want to host in the cloud. So these are all the various database related service what AWS offers. So why the organizations are opting for managed database services in the cloud? So it is typically to ease the administration tasks that are performed by the DBAs. We call them as the database administrators. And also to enable them to automate some of their day-to-day tasks. So that's the reason most of the organizations are opting for the managed database services offered by the cloud. So if at all we are opting for a managed database service, so what are all the various services that are provided by the cloud provider, like AWS or Azure or GCP? So these are all the common infrastructure what is provided by the cloud. So it all starts up with the power infrastructure, providing the rack for hosting your database servers, taking care of the server maintenance, installing the operating system on the DB servers, installing the necessary operating system patches, then also installing the required DB software. It can be a Oracle or a MySQL or a MySQL, PostgreSQL, etc. Whichever database the organization is using, and also to install the DB software patches, backing up the database. So that is another important advantage what we have on the cloud. The backup methods that are used by the cloud provider is quite simple. So database backups can also be automated using the cloud. Then there is a high availability of the databases that also can be provided within the cloud infrastructure. And if at all you want to automatically scale your database size without any manual intervention, that scaling option is available in the relational database service provided by the cloud. So if you see all these options, whatever is marked in red, it's all taken care by the cloud provider. So from the organization standpoint, they just need to look into the task of optimizing their application, optimizing the queries, the SQL queries, etc., which will in turn improve the database performance. But from the infrastructure standpoint, everything is taken care by the cloud provider. So that is the reason this point is very important. If the company is opting for managed database services in the cloud, 90% of the management is done by the cloud provider. So that only the 10% effort the company has to spend on optimizing their applications. Okay, now let's get into the lab demo for how to launch a MySQL RDS in AWS. Before that, I just wanted to share a prerequisite. This is assuming that the setup with a VPC is already there. I already have a VPC, a virtual private cloud, that is set up with both private as well as a public subnet, right? So I'm running a web server which is on a public subnet, and I'm also running an application server that is on a private subnet. So this setup is already there. So this is typically going to involve the setting up of VPC, setting up the subnets, the routing tables, etc. So if at all you want me to put a separate video on VPC, how to set up a VPC, how to set up a public subnet, private subnet, how to configure the route tables, how to configure internet gateways, NAT gateways, etc. You can put it in the comment section. I will make a separate video on the VPC lab demo. Okay, so we already have this setup as a prerequisite. Now, what are all the steps that I'm going to do? I'm going to launch a MySQL RDS in the private subnet, because generally your application and the DB servers, they all will be hosted on a private subnet, right? Once the MySQL RDS is launched, I'm going to access the database from the application server, which is again residing in the private subnet. Then after we access the database, after we log into the database, we will try to perform some CRUD operations on the MySQL database. So these are all the various steps that I'm going to perform as part of the lab. So let us go ahead and launch the MySQL RDS. So as I mentioned before, I already have a VPC setup with the private and the public subnets. And I have a web server that is hosted inside a public subnet. And there is an application server that is running on a private subnet. So let me just show you that in the AWS console. So here, if I go into the VPC, the VPC is here. You can see it. This is the VPC that I have. And under this VPC, there are two subnets that I have created. One is a public subnet and the other one is a private subnet. Let me click subnets here. And these are all the two subnets. So this public subnet, it's running the web server, and this private subnet is running the app server, right? On this private subnet only, I'm going to launch my RDS also. Okay, so generally, we know that the web server should be always running on a public subnet. Application server and the database server should be on a private subnet, right? So I'll go ahead and launch the RDS MySQL in a private subnet. So what I will do is, let me go ahead and search for RDS, Managed Relational Database Service. So I will click DB instances here, and I will say create database. So here we have the engine options. So I will go with the standard create, and in the engines, these are all the various database engines that is provided by AWS. So we have Aurora, that is MySQL compatible. It is another managed service that provides high availability for your MySQL or PostgreSQL databases. So we have two engines, one each for MySQL and one for Postgre. Then we have a separate engine available for MySQL. Then we have one for MariaDB, PostgreSQL, Oracle, and Microsoft SQL Server. Right? So now we want MySQL database. So I'm going to select MySQL here. And we can select the engine version. I'm going to just leave it to the latest version. And so in the production environment, if at all you are launching your database for a production environment, then we have three options. We have a multi-AZ DB cluster new, and we have a multi-AZ DB instance. Then we have a single DB instance. So maybe for our lab purpose, I'm going to select the environment as development test, which is going to come up with a single DB instance. And here you can see the master username. It is by default taking as admin, and I'm going to give it a password. We confirm the password. And for the DB instance class, the standard class is basically going to include a higher configuration EC2 instances. So based on the use case, the organization has to select the appropriate class of the EC2 instance. But for our lab purpose, I'm just going to select burstable classes here, and I will go with this DB T3.micro instance, right? So storage type, again, you have the option to select the appropriate storage types. I will go with general purpose SSD GP2. Then allocated storage, by default, the database is going to have a storage size of 200 gigabytes. But there is an storage auto scaling option available. If at all you want to enable this option, have the check mark placed here. And you can also provide a storage threshold, right? So whenever this particular storage threshold is hit, automatically the storage size is going to increase. So in our case, the storage threshold is 1000 gigabytes. So I'm going to just leave it like that. So whenever the database is going to hit the size of 1000 gigabytes, it is going to scale automatically. Now, with respect to the connectivity, we can just leave it to don't connect to an EC2 compute resource, because anyway, we are going to manually connect to the database from the application server. And public access, yes, we will generally give it as no. We generally don't enable public access for your application server and databases, right? We have to, that's the reason I'm going to host it inside a private subnet. Now, VPC security group. So to which VPC I want this database to be part of? So we can select a new security group, or maybe I'm going to create a new security group here. And I will say test SD RDS. So in which availability zone I want to launch the database? Basically, no preference. Maybe I can leave it to the one of the availability zone within the Oregon region. Then database authentication, I'm going to leave it to the password authentication. And if at all you want to enable enhanced monitoring for your databases, which is going to collect some additional metrics in regard to the database performance, you can enable this enhanced monitoring. And again, it is going to collect the metrics at a much lower frequency intervals. And that is a chargeable service. So if at all you want to enable that, we can enable that. And now let's go ahead and create our database. So let me just verify the configurations again. Okay, yeah. So basically, I have to select our custom VPC here. Currently, you see that it is pointing to the default VPC, right? But I want to host our database within a private subnet, whatever I have created under this VPC. So I'm going to select my demo VPC here. And we can also create a subnet group for this database. So DB subnet group. Okay, anyway, we can leave it to the same setting, and let's go ahead and create the database now. So what is the master username? I'm going to say admin again. Let's create the database. So it's suggesting some add-ons for the databases. It's not required at this point of time. So I'm just going to close this tab. Now you can see that, it is in the process of creating the database. So it's going to take a while here while it stands up the database. So now the database has been provisioned successfully. You can see that the database is in the available state. So let us try to go through the attributes of this database. So you can see that it has generated an endpoint. So we can connect to the database only through this endpoint. And MySQL by default runs on the port 3306. And you can also see that it has been launched in this VPC, which is my custom VPC. And there is a security group what we created for this database. And we will see the rules on this security group. So if I click this, and if I go into the inbound rules, so you can see that by default, the SQL port, MySQL port 3306 has been open for my private subnet. Right, so this is the CIDR for my private subnet, and already this port has been enabled for my private subnet. So from the application server, which is residing in the private subnet, I will be able to access this database. So let me go back to the VPC dashboard here. And if I go into the subnet, so this is our private subnet, and I was mentioning that this is a CIDR for the private subnet 10.0.0.32/27. So now we will see how to access this RDS instance of MySQL from the application server, which is residing again in the private subnet. So I'll go to my EC2. And if you see the instances, so these are all the two instances that is running. Web server is in a public subnet and app server is in a private subnet. So first, let me log into the web server, and from there we will try to log into the app server, and from the app server we will try to access the database. So first let me log into this web server. I'll grab this IP address. It is saying it's refused the key. Maybe I uploaded a wrong key, I guess. Let me check the key for this. 4923. Okay, now I have logged into the web server. So from the web server, let me try to log into the app server. So in the security group of my app server, I have enabled access from the public subnet. So I should be able to do an SSH from my web server to the app server. And let us just double check the security group. So if I edit the inbound rules, you can see that I have allowed access, SSH access, and this is my public subnet CIDR, right? So I have enabled access to all the EC2 instances which will be hosted inside this public subnet 10.0.0.0/27. So now let me try to log into the app server from my web server. So I will say SSH EC2-user, and I will take the private IP address of the application server. So what is a private IP? Because since this is an application server inside a private subnet, we don't have a public IP for this. So straight away I will copy this private IP. And it's asking me if you want to continue connecting. I will say yes here. And you can see here, team, there is a permission denied message. So how do you address this? So this can be addressed by doing the key forwarding from my system to the web server, which in turn will forward the keys to the app server that will provide a temporary authentication. So what I will do is, so there is a utility called as Pagient. So I'm going to use this utility for the key forwarding. So if I click this Pagient, it is asking me to add a key. So I'm going to upload the key, the private key, whatever I'm using to log into my web server. Now this key has been uploaded in Pagient. Now I'm going to open a new session. And here, let me give the web server public IP and SSH. I'm going to add the same private key, that is this one, 4923. And if I go to auth here, you can see this option, allow agent forwarding. So if I enable this, from whatever server you are connecting from the web server, the keys are going to get forwarded for that particular session. So that way you can get authenticated to that application server as well, right? So let me enable agent forwarding. And now we will try to log into the web server. Sorry, there is a typo in the username. Okay, so now I have logged into the web server. So now from here, let me try to log into the application server. So SSH EC2-user, right? Let me take the private IP of the application server. It's 10.0.0.37. Now you can see I am in the application server. And from here, let me try to access the database. So I will just say telnet, and I'm going to take the endpoint of the database. Let me go to the RDS dashboard. Okay, so this is my database. And this is the endpoint, right? So basically we can connect to the database only using this endpoint. So I will do a telnet, this particular endpoint, and port 3306. So telnet command is not found. So we may have to install telnet on our application server. Since this is inside a private subnet, we will not be able to install it unless and until you enable connectivity to the internet, right? So what I will do is, let me try to launch an NAT gateway which will enable internet connectivity from the private server, and I will install telnet on this machine. So I managed to install telnet on this app server by using a NAT gateway. I spinned up a NAT gateway and enabled internet connectivity, and I was able to install telnet on this machine. So when I try to do a telnet to the database endpoint and to the port 3306, you can see that I'm able to connect to the database from here, right? So now in order to actually connect to the database, this being MySQL database, I need to have a MySQL client installed on my application server, right? So again, I'm going to use this yum command, yum install MySQL -1 in order to install the MySQL client. And using the MySQL client, we should be able to connect to the MySQL database. So now how do we connect to the database? Now MySQL has been installed. So let me use the proper parameters to connect to the database. So the format is MySQL -h. That is a database host name. So what is the database host name? This is nothing but the endpoint of the database. So I'm going to copy this endpoint. MySQL -h, the database endpoint, minus capital P, which is the port, the MySQL port, and the port number is 3306. and -u, which is the username. So -u is the switch for username. So what is the username? It is admin, and -p is for password. So I just give an enter after saying -p. Now it is going to ask me for the admin password. So whatever password that I created during the launch of the RDS instance, I'm going to specify it here. Now you can see I am into the MySQL database. Right? So this is how we log into the database. This is the syntax, MySQL. Then you can say -h, and this is the database endpoint. -h is the switch for it. Then -P, the port number. Then -u, the username, and -p. Then type your password for the admin user. So now we will try to execute some commands on the database. So if I give the command show databases, you can see that I'm getting the output of the default databases that is available. Now, if I want to create a new database, I will say create database test. Okay, you can see here the query is okay. Now, if I give show databases command again, you can see that this test database is also created. This is how you launch the MySQL RDS, and using MySQL client, you will be able to connect to the database. So in this case, we have connected from the Linux EC2 machine, our application server. So if at all you want to connect from a Windows machine to the MySQL database, you can use the tools like MySQL Workbench, etc., using which you should be able to connect to the database, even from a Windows machine. So I hope this video was helpful on the RDS, how to stand up an RDS in AWS, and how to connect to the MySQL database. So please feel free to put in your comments, and if at all you need any specific content on the AWS front or DevOps, you can feel free to put that as well in the comments. Also, just wanted to let you know that I'm also offering training courses on AWS and DevOps. So if at all anyone would be interested, you can feel free to send an email to this particular email ID, and I will provide the details about the course, the fee structure, etc. So just to quickly highlight that the training will be taken via the Zoom. It will be Zoom sessions, and class recordings will be uploaded onto the Google Drive, and the access will be provided to you. And it is going to be 5 to 6 weeks of interactive course, completely focused on the hands-on lab exercises. So if anyone interested to take up an offline training session from me on either AWS or DevOps or both, you can please send an email to this mentioned email ID. So thank you all, everyone, and I will meet you in my next video.